Hello and welcome to class. In this video, we will be studying about similar triangles, or what is known as congruence of triangles. Two triangles can be said to be similar if they satisfy some given conditions, and we're going to look at those conditions. So you might have two triangles. By just looking at them, they might appear to look different. However, they can be similar if certain conditions are met. Now we're going to take our time to look at those conditions that the two triangles will need to satisfy before we can say that both of them are similar or that they are congruent. That's another way you want to put it: similar triangles or congruent triangles. Now, the first case, the first proof for similarity of triangles is what we know as A. All right, A standing for angle, angle, angle. So in other words, if you have two triangles, say for instance you have triangle A, B, and C, and you have another triangle, let's call this one now D, E, F. Now these two triangles can be said to be similar or congruent triangles if all their angles are equal. Now it doesn't matter, looking at this one now, you see that it is big, right? It is bigger in size than this one. However, if all their angles are equal, the three given internal angles, if they are equal, then we can say that these two triangles are similar. In other words, if you have an angle here A is equal to the angle here D, you have an angle here B being equal to the angle here you have at E, and then you have the third angle here being equal to the third angle here. In this case, we can say that triangle, I want to write that triangle A, B, C is similar or congruent. That's like three dots, like these three lines, is similar or congruent to triangle D, E, F. And then the reason being that what they have three angles equal, A. So this is the first case. So when we have two given triangles, and when you take your measurement or analysis, and you find out that the three angles that are contained within those two triangles are the same, then those two triangles become similar triangles. All right. Some other textbook, you see them write similarity like this. They'll write it that triangle ABC. So triangle ABC is similar to triangle DEF. So either way, whether you use this sign to show congruence or this, or they call it like this, something like, yes, to show it, still the same thing. All right. So that is the first case, first test of similarity. When the triangles or the two triangles have all three sides equal, then we say that they are similar triangles. All right. Now the next case, the next test for similarity of triangles is what we know, or what is called as SAS. Now you might guess what this means. That is side, angle, side. So when we have two given triangles, in this case, let's say we have this triangle here and we have this other triangle here. All right, we have these two triangles. Okay, let's label them. So let's say we have X, Y, and Z, and we have A, B, and C. Okay, so if it is such that the sides of these two triangles are equal, or the ratio of the two sides are equal. What I mean by ratio is that now we have two sides here. Let's use this side and this side. So that means we're using these two sides. So if it should be that the ratio of these two sides, that is when you have, oops, all right, so you are having side xy, consider side xy, that is this particular side. Now this particular side corresponds to here in your triangle ABC, all right, and for your yz corresponds to BC, right? Your xz corresponds to AC. Okay, so you must make sure that the sides you are trying to test are corresponding side. You cannot talk about xy and BC being corresponding sides. No, you have xy and AB being corresponding side. So if you want to test for similarity of this triangle using this second postulate, that is the side angle side, it means that the angle in between the two sides must be equal. So if the angle here is equal to the angle here, that is the first criteria, angles, then you have the sides that form the angles if their ratio is equal. That is, so if you have xy now, that is side xy over the corresponding side, which in this case is AB, all right, is equal to, also when you find the ratio of these two sides, remember it must be the two sides in between, wherein you have the angle formed in between. Okay, so if the angles here are similar, that means you are talking about these two sides. It must be the sides where you have the angles formed in between them. So we are looking for if the ratio of our xy to the corresponding side AB is equal to the ratio of yz to that of the corresponding side, which is BC. That's BC. That is, in other words, when you divide them, we're going to solve examples to for you to understand what we mean. So when these ratios are the same thing, then we can say that since, and then you have that angle, the angle is y, you know, your angle y is equal to the angle B. All right, this caret sign is like it shows angle, so the angle y is equal to angle B, and then the ratio of the two sides are equal. Then we can say that the two triangles are similar. We can then go ahead and write that triangle x, y, z is similar or congruent to triangle A, B, and C. Okay, so that's the second case for similarity of triangles. Now the other one that we want to consider, let's consider the third example, which is the case of what we call angle side angle. All right, so we have angle side angle. That is when two sides or two angles are equal, and then the side, one of the sides or two of the sides are also equal. That is one of the sides of one triangle. That is, you have a triangle here, you have another triangle labeled A, B, C. You have also let's D, E, and F, such that the A is equal to your D, okay, and then the angle here B is equal to here, and then this side in between the angles, in this case that is A, B, and then the DE, these two sides are equal. Then we can say that these two triangles are similar because they have two angles equal and one of the corresponding sides also equal. So in this case we can make the argument that both triangles are similar, even though they might not appear to be the same by just mere observation, but when all these criteria are met, we can be certain that triangle is said to be similar. Now let's look at some worked examples to show you, to bring into perspective what we have been doing so far. Consider these two triangles. Alright, consider these two triangles. Let me call this one X, Y, Z, and let's have another triangle here. Let's call it A, B, C, such that we have here to be 12, we have here to be 15, and we have here to be 18. Then for this triangle, we have here to be, let's say here is 4, here is 5, and here is 6. Now looking at these two triangles, are they similar? Are they similar? Okay, when you draw them to scale, this one XYZ having the scale of 12 cm on one side, 15 cm, 18 cm, then the one you're having 4, 5, and 6. Are they similar? Well, you just have to test it out to know whether they are similar. Now the sides are given, so what you want to do is to check for the ratio of the sides, the corresponding sides. Are they equal? Alright, so you identify the sides that correspond to each other and then find their ratio. That by ratio will mean you divide them together to see what you get. So in this case, let me change the marker now. So you will see that XY corresponds to AB, YZ corresponds to the YZ corresponds to BC, and then XZ corresponds to AC. So what do? We test those ratios. So the ratio of XY, that's 12 over the corresponding side to XY is what? AB, that's 4. We'll find the ratio 12 over 4, that will give us 3. Check for YZ. Your YZ is 18. It corresponds to BC, which is 6. When you divide that, you have the same 3. Then your XZ is 15. When you've divided by the corresponding side in the triangle, which is what? 5. Then we divide that, we'll have 3. So in this case, you are seeing that the ratio of all the sides 3, 3, 3. That means that triangle XYZ is similar to triangle ABC. Triangle XYZ is similar to triangle ABC. So in other words, when you do this, you must, for them, if you test all the 3 sides and then you're having varying values, you have having different values, that means that they are not similar. But in this particular case, we have 3, 3, 3 across board. That means that the two triangles are what? They are similar. All right. Let's also look at another example. Okay. Okay. Let me use this one now. So let's say, let me go ahead and okay. So let's say that we have this triangle. We have this triangle. We have this triangle. Now this is gonna take a different shape. Now we have two triangles here. This is 12. This is 7. Alright, this is 24 here. Let's see that here is 24. This is not drawn to scale, so this is 24 here, and let's say that here is 14. Here is 14, and then we have a triangle labeled A, B, C. Then we also have D, E here. Alright, now the question is, you are being asked, is triangle ADEE E similar to triangle ABC. I'm not so yeah, the question, that's the question now. Triangle ADE congruent to triangle ABC. That's the question we're trying to find out. Are they similar? Are they similar? Triangle ABC and then triangle ADE. Okay, let me try to highlight, because this is one shape, but inside it you have two triangles. Look, this is the second triangle here, ADE. Well, that's the bigger. That's from your A down to your B down to your C. That's the bigger triangle, but you have the smaller one, ADE, inside of it. So the question now becomes, are they similar? Now, how do you check for similarity? How do you test whether these two triangles are similar? All right, now one way you want to do, one thing that you want to do is to try to separate the two triangles that you have. So if I should do that, let me try to separate that. So if we do that, we have two triangles. It has a bigger triangle, which we will label to be A, B, C, and then we have the smaller triangle here, the one inside of it, which we are going to label A, D, E, and of course you label the sides. Now for the smaller triangle A, D, E, we have here giving us 7, and we have this side giving us 12. But for the bigger triangle, what will be the length of from here to here? That's AC. Now AC will be when we add this and this. Alright, so 7 plus 14, that will give us 21 as AC. And for our AB, from here to here, we'll have to add these two lengths. That is 12 plus 24, and that will give us 36. So we just have two sides given in this given this particular triangle. Two sides are given. All right. So, but it's not enough for us to know whether they are similar. However, remember that we said that there are three different postulates, or three different conditions that we can test to ascertain whether two triangles are similar, and one of them is the case of side, angle, side. All right. So two sides given and then the angle in between them. So what you have to first of all identify is whether these two angles that are here, are they similar? Are they the same? Now when you go back to the original shape, this A, the angle here at A is common to both the bigger triangle ABC and also the smaller triangle ADE. In other words, we can boldly say that, or make the claim that these two angles here are equal, no matter what they are, no matter what the value is. We don't know what the value is, but no matter what the value is, the angle here A is equal to the angle A in the smaller triangle. All right, so that's the first case. So that's the first case, that they have the angles equal. That is one. Then what the next thing we need to do is to ascertain whether the ratio of the corresponding sides are equal, just like we did before. So we have to, even though we have 36 here and we have 12 here, we don't just dismiss that. We have to ascertain, check their ratio. That is, divide those corresponding sides and know whether they will give you the same ratio. So in this case, let's say 36, that's the ratio of AB. So I want to find the ratio of AB to AD, but they are corresponding sides. So ratio of AB to AD, that will mean 36, which is AB, over AD, which is 12. And when you do that, that gives you 3. That is 1. Then you also check the other sides, that is this side and this side. What is their ratio? Is it still the same thing as that of the one that you've already gotten? So I want to test for the ratio of AC to AE. So ratio of AC to AE, and the AC, that is for this longer side, that is 21, and AE is 7. So when we divide 21 divided by 7, that will give us 3. So in other words, for this particular triangle, the equation triangle ADE is congruent to triangle ABC. Now the answer is yes. And what is our reason? Because we have side, angle, side. The two sides have the same ratio. When you divide that is the two corresponding sides, they have the same ratio when they are divided, and the angle in between them, A, is equal. Even though we do not know what the value of that angle is, we don't need to know the value of the angle for us to make the case for the similarity. Okay, but the argument is valid. This A is common to both the bigger triangle and the smaller triangle. That means that it must be the same angle. And because that is the case, we can then go ahead and make the argument that they are the same. Then we'll go ahead and test for the other two sides. Their ratio, remember, it is always the ratio you're looking at. So you don't just look at 36, look at the other side 12, you say they are not equal. It means that no, it is always the ratio that you want to check out. You want to check out the ratio to make sure that they are not the same. That is, you divide the corresponding side. Don't make the mistake of dividing, maybe in this case 36, you can divide it by 7. They are not corresponding sides. All right, when you study the triangles, the side must be built exactly the same way for them to correspond. So here's the base, here's the base. This one is standing side, here's the standing side. This is the slant side, this is the slant side. So that's why you have to make sure they are corresponding sides, that you are finding the ratio. They are dividing the corresponding sides, not just any side that you see. Okay, so this is what we mean by similar triangles. That is that two given triangles can be similar, even though that they might appear different when you look at them, but they can be similar. That is the concept we are looking at. All right, so in the next video we'll explore that thought further. We'll even look at that further, and even okay, in our next video we'll also take that thought further, because when you look at these two triangles, even the angle here is equal to the angle here because they are corresponding angles. But we're going to continue in our next class. So for now I'm going to go ahead and give you some tests. I'm going to go ahead and give you some so that for you to check whether they are similar or not. Now this is a triangle. This side is parallel to this side. Let the parallel sign not confuse you. So we have here to be 7 cm. We have here to be 5 cm. We have here to be 5.6, and then we have here to be at 5.6 cm, and then we have here to be 4 cm. So let me label them: P, Q, R, P, Q, R. Then here let it be S and then T. So what I want you to find out is triangle PQR, triangle PQR, is this similar to triangle PST? So this triangle, you have two triangles here, PST and PQR. Are they similar? Are they similar triangles? So you might want to go ahead and check out, use the postulates that we've looked at, whether angle, side, angle, side, angle, side. All right, so we'll know which of them that will work, and then try to know whether they are similar or not. So I'll be seeing you in our next class. Bye.